anyways, now the next part is, now let's take a look at problem 6. And this is looking at a largest sphere in a sphere. So it's a sphere within a sphere. So it's going to be quite epic stuff there. So, alright, in this question we're asked, find an equation of the largest sphere that passes through the point -1 and 1 and 4, or yeah, -1, 1, 4, and is such that each of the points x, y, and z inside the sphere satisfies the condition x squared plus y squared plus z squared is less than 136 plus 2 times x plus 2y plus 3z. Alright, so now let's take a look at the solution. So to grasp what this is asking, exactly, because this is a sphere equation right here. This is going to be the radius, but now we have these x, y, and z terms. But if we complete the square, this just means that the origin of the sphere is shifted. So let's complete all the squares first. There's a link to my earlier video, but basically it's pretty straightforward. I'm going to write this all down. So we have x squared plus y squared plus z squared is less than 136 plus 2x plus 2y plus 3z, like that. Alright, so now the next setup is I'm going to move over everything to the other side. So I'm going to move all these to the other side, this, etc., this, and separately, and look at them separately. So what we have is, yes, we're going to have, we're going to go like this. We're going to go x squared minus 2x, so we multiply 2 inside, and then we'll have plus y squared minus 4y, and then we're going to have plus z squared, and then it's going to be 6x, z squared minus 6x, 6z, and then this is going to be less than 136. Like that. Alright, so now we have this. Let's complete the square for each one. So let's do the x one first. So that's this right here. So we'll simplify it. What I mean by that, completing the square, recall, this just means, let's say we want it in this form, x minus a squared. So x minus a squared, this would equal to, let's go, just FOIL this out. So x times x squared, yeah, is x squared. X times negative a, x times, negative a. Or just, x times minus a is just going to be negative ax. And then now we do this one, multiply this out by that itself, by x and itself. So FOIL it out. So negative a times x is just going to be negative ax. So that's the two of them. So we just add those up. And then lastly, negative a times negative a is going to be plus a squared. Alright, so basically we want this to match up with this part right there. So in other words, it has to equal to x squared minus 2x. And to do that, well, a is just 1. A is 1. A equals to 1. So in other words, this is going to be plus 1 squared is just 1. So now we can move this over to the other side. So move this over to the other side. And then what we end up having is we're going to get x squared. Yeah, so x squared minus 2x equals to x minus a squared minus 1. So that is this part here. So we can replace it with this square. And now we've gotten rid of the x, and one of the x's we put it inside the square. Now this is the origin, and this is a. I mean, this is a is 1. So a is 1. Yeah. So basically, the sphere is going to be shifted to the x equals 1. So when you plug in 1, it goes to the origin 0. So yeah. So that is at the origin is at shifted by 1. So that's that one. So the next one is going to be this part right here. So y squared minus 4y, so we'll complete the square for this one. So this is going to be y minus a squared. This equals to, again, the same thing as over here. This is going to be y squared minus 2ay plus a squared. And in this case, this has to equal to y squared minus 4y. So this is going to equal to y squared minus 4y. So in other words, a is equal to 2. A equals to 2. And then this means this is going to be 4 now. A squared is or 2 squared is 4. So then solve for this one right here. We're going to get y minus 4y equals, so when we move this over to the other side, this goes all the way to the other side. We're going to get y minus a is 2 squared, and then this is going to be minus 4. I'll just move this over to this like that, and this is going to be, yeah, so we can replace this one replace this with this right here. Alright, so now the next one is going to be, and this is going to be this right here, the z. So again, the exact same thing, z squared minus 6z. So we're going to have z minus a squared, that's equals to z squared minus 2az plus a squared. And then this has to match up. So z squared minus 6z. So in other words, a is going to be 3. So 3 times 2 is 6. So a equals to 3, like that. This is going to be 3 squared is 9, like that. And then solve for this one here. So again, take it over to the other side. We're going to get z minus 6z is equal to z minus a, which is 3, squared, minus 9. So this is that. Alright, so that's what we could do, is add these all together. So so replace them all. We're going to get right here. So this part here is going to be x squared minus 2x. That's going to be x minus 1 squared minus 1. And this other one's going to replace it with this right here, y minus 2 squared, minus 4. This other one's 3, and there's a 9. So thus we're going to have x minus, let's go right here, x minus 1 squared, and the other one, we want to put all the x and y's in the same order. So I'll move this negative 1 to the far end. So I'll put it right here, like that. The next one's going to be plus y minus 2 squared. This is y minus 2 squared. And then next is going to be, and then also put the negative 4 right here. Negative 4 like that. And this is going to be plus z minus 3, 3 squared. And this is going to be, and I'll just shift this over. This is negative 1, negative 4, negative 9. And this is going to be less than, equal to, less than 136. 136. Alright, so that is what we have. And now this part right here, we could sum these up. This is just negative 1 minus, we'll just add these all together and put a negative. So 1 plus, or negative 1 minus 4 is negative 5. Minus 9 is going to be, minus 14. So in other words, 1 plus 9 is 10, plus another 4 is 14. So 14. It's going to be negative 14. So we're going to have to add 14 to this. 136 plus 14, that's just 150. So out of 4, it goes 140. And the next one's going to be 150. So add another 10. So this means we get x minus 1 squared plus y minus 2 squared plus z minus 3 squared. And this is going to be less than 150, like that. So this is what we have. And this is just a sphere. So this is a sphere. With radius is going to be, square root 150, like that. And we can simplify this further. Well, the solutions manual does. So this is the same thing as writing. Well, let's split these all up into multiples. So 15, the same thing as writing, 10 times 15. And then this is the same thing as writing 2 times 5. And this is the same thing as writing, this is going to be 3 times 5. So in other words, we're going to get a 2 times 3, which is a 6. Square root 6. It's going to be, we'll put that in the square root. So I'll put that right here, square root 6. And the next one is going to be 5 times 5 is squared. So I'll put it all completely just so we don't get too confused. So this is going to be something as writing, 5 times 5 is squared. The other one's 2 times 3 is 6. And this is going to be canceling out the squares. We're just going to left with 5 square root 6. So that's the radius. And here I just shifted this down here so we could put the center right here. So just center on top instead. So center like this. So center is going to be at 1, 2, and 3. So basically the negatives of every one of these. So that's the center. And the radius is over there. I'll put an equal sign instead. Alright, so the center of this sphere is at 1, 2, 3, and the radius is square root of is 5 times square root 6. All right, now that we have this, so again, this is just a sphere. This is a sphere, just fix that up. So this is a sphere which describes a set of all points x, y, and z whose distance from the point P. We'll call that P at the origin right here. We'll put a P right here. is 1, 2, 3 is less than 5 times 5 times square root 6, or 6 power of 1/2. It's not easy to do square root in this one note thing like that. So this is less than it. So the sphere radius is going to be less than. I'll put instead of equals, put less than, because the radius is a set of all points less than this full sphere. Alright, and now the distance from P to Q, we'll put Q as the point we were asked, so -1 and 1 and 4 is, and I'll illustrate that soon, but let's go back to the question. So the question is, find an equation of the largest sphere that passes through the point -1, 1, 4, so we'll call this Q. I'll just put call this Q, like that. And it's such that each of the points X, Y, Z inside the sphere satisfies a condition like this. Yeah, so we need to have a sphere that basically lines up with this, but it's also such that it's inside it satisfies this condition right here. So all these points have to be less than a actual sphere inside. Yeah, so it's actually going to be a subset of a sphere inside a sphere. All right, so now go back to that drawing right here. So we have this right here. So we need to find out the distance from here to here. This is what we're getting. The next part is this is P, this is Q. So finding the center. This is from Q to P. All right, so this is distance from P to Q is, and we could just basically use the 3D geometric formula for it, and that's just going to be again, as an earlier question went over it. So PQ, the distance, or the absolute value sign like that, is going to be equal to, and here we just subtract each term. So we'll just go P to Q. So -1, or I'll go 1 minus -1. So 1 minus -1 is going to be +1 squared. And then 2 minus 1 is going to be, oh, why is it doing that? Okay. Yeah, this is going to be plus, right, plus, I just fixed that up. This is going to be 2, minus 1 squared, and then the next one is going to be 3 minus 4. And then all squared. Yeah, so this equals to square root 2 squared plus, and then this is going to be 1 squared, plus this is going to be 3 minus 1. It's going to be -1 squared. I'll just get rid of these pluses. Do it all right away. So 1 plus 1 is 2 squared. 2 squared is 4. And the next one is 2 minus 1 is 1. Squared is 1. -3 minus 4 is -1 squared. It's going to be plus. It's going to be 1. So this equals to square root 6. All right. So that's the distance from P to Q. Yeah, so thus the largest possible sphere that passes through Q and satisfies the stated conditions extends 5 times square root 6 units in the opposite direction, giving a diameter of 6 times square root 6 as in the diagram below. Alright, so here instead of a circle, here's just a placeholder. We'll modify it in a bit. So what we have is, let's say we have the point Q right here. Let's say we have Q here is going to be this right here is Q. This is at -1, 1, and 4. Just double check that. Yeah, so -1, 1, and 4 right there. And the distance from that to P, so P is going to be somewhere across to there. Yeah, I'll put a line like this. This is P. And this is, I'll write this as P. It says 1, 2, 3. And basically it's like this. So 2, this is -1. It's going to be, let's just shift it to the right, by 1, by 2 units. The next one is a bit down, and then I'll just put a random point like that. Anyways, so that is our point P, but I'll do this like this. Alright, so we have this. Alright, and this is the point P like this. So that's P. Actually, I'll put it better like this. And now this distance is square root 6. So that's square root 6, like that. Alright, so let's move it down here. So if this is the point P, and this is distance square root 6 from Q, and we have the condition that, basically the condition is such that this right here, so every point inside the sphere has to satisfy this condition. So in other words, it has to be less than a sphere of radius 5 times square root 6. So in other words, every one of these points has to be less than a distance, and we'll draw this all the way across here, less than all the way up to here, and this is going to be 5/6. Yeah, this is 5 over 6. Like I mean 5 times square root 6, not 5 over 6. 5 times square root 6. Let's move that dot away. 5 times square root 6, like that. So in other words, this is a sphere, the condition. So I'll put this right here. So we start from here. And this sphere is actually what we're trying to solve. This actually goes up to here. And let's just move this all the way back. So we have a sphere like this. And this is what we want to find. So we're finding the largest possible sphere that passes through Q. So passing through Q and satisfies the conditions that it's going to be less than basically the farthest distance right there. It has to be within the other sphere of the radius 5 times square root 6. So in other words, this right here, and if this is, so basically what we want to do is find the center. So we want to find, what I'm going to do is put this 5 over 6 like this. 5 square root 6, because we want to know the center of the sphere. This is what we want to find. But we also have another sphere, just to illustrate the big sphere is a condition it needs to solve. So basically a sphere within a sphere. This is going to be right here. But then the center of this is going to be extend all the way until the center is at P. And to get this exact sphere there, I'm going to take this. This is the radius of the center P. I'll move this like this. I'll move it all the way here. So move it right here, and we'll rotate it all the way. Actually, I'll rotate like this. Let's rotate it like this, so it's exactly the same length. So that's the diameter. Yeah, so it's pretty much, we almost got it exactly it. So let's get back to our sphere. This right here, move it a tiny bit bigger. Okay, move it like that, and exactly that. Yeah, so that is at that point P, and this is also square root, this is radius also. Like that. And this is, I'm going to call this point right here C. And this is 5 square root 6, and this is also 5 square root 6. This is also, I'll put a light like that. This is also 5 square root 6, like that. Alright, now here I just move this over here. So thus the desired radius of the radius of the desired sphere is 3 times square root 6. Actually, I forgot to get over that, but basically we can solve this because this full distance right here this is square root 6. It's 5 over 6. So I'll move this actually over here, and then this is from here to here is just so it's you can see it better. This is square root 6. So in other words, the r right here. So this is the one we want. It's called, yeah, so this r is going to be equal to, well, the full diameter is going to be square root 6 plus 5 square root 6 all divided by 2. So in other words, add those up, we'll get 6 over square root 6 over 2. Like that. This is just going to equal to 3 square root 6. Like that. So that's our desired radius. So that's our desired radius. And we know the equation of the big sphere, and we know that Q is a distance square root 6 from the center of the big sphere. So we can calculate the equation of this smaller sphere. Alright, so let's continue further. So basically, thus the radius of the desired sphere is 3 times square root 6, and its center is 3 times square root 6 units from Q in the direction of P. So it's going down here like that. So we could use a unit vector in this direction, but first recall unit vectors. Recall from earlier video. It's a link to it and the thumbnail. So unit vector right here. If you have a vector right here, A, like that, this is A. Unit vector is just a length 1. And it's in the same direction as it, so it's parallel to this one. So it's exactly on it. It's a unit vector, and the unit vector you can calculate it by taking the vector A divided by the length of A. So that the unit vector absolute value of its length is just 1. So that's all a unit vector is. So thus a unit vector in the direction of from Q to P is, so we go from Q all the way to P. Let's just draw these all out. So we have Q right here. Now it's going to go, this is P right here. So unit vector is going to be right over here. I'll call this U. And again, we know this length is square root 6. So then a unit vector in that direction is going to be equal to, well, we got to get the full position vector right here. I'm going to put right here, this is from here to here. The full one is QP. Or actually, we already have that. I'm going to put an arrow right here. So we already have QP right there as a vector, the full one. This is the full one. I'm just going to put QP like this. Whoops, Q. P, put an arrow. So this is equals to basically QP divided by the length. And the length is going to be, let's put it for completeness, QP like this, position vector. This equals to, this one here we just subtract 2, so P minus Q. And P is 1, 2, 3. So we're going to get 1 minus, and then this other one is, Q is, we know Q is negative 1, 1, and 4. So it's going to be minus negative 1, so it's going to be plus 2. Plus 1. And this is in vector format like this. And we already solved the other one. Yeah, so P is going to be 2 minus 1 is 1. I'm just going to go put 2 minus 1 just for completeness. And the next one is 3 minus 4. Like that. Like this. And this whole thing is divided by square root 6. So in other words, this is going to be 1 over square root 6. And then this is going to be 2, 1, negative 1. Like that. So that is our direction vector along the direction from Q to P. Alright, so now if we extend further out all the way to C, so this is up to C, and what I'm going to call this vector from Q all the way to C as QC. So basically like this to this. This is QC, and its length is just we already know this one. The length from Q to C is the radius, so it's going to be square root 3 times square root 6. So this is going to be it's going to be 3 square root 6 like that. Yeah. So then QC, we can solve QC because remember QC is just this direction vector like that. So we just if it's always 1, so this QC is just going to be equal to always multiplied by the position vector. So we just go to QP. Actually, not QP. We just multiply by the position vector and the length. Because this is just length 1, so we just multiply by the full length. So in other words, we get 3 square root 6 times by U position vector. This equals 2 because it's all along the same line there, same direction. So this equals 2. So what I'm going to do is multiply this inside there. So this is going to be, I'll put this like this, 3 square root 6 over square root 6, and then this is, just put that in here, 2, 1, negative 1, like this. And then this would cancel, and then move 3 inside. So this equals 2, 6, 1, 6, 3, negative 3. Like this, 6, 3, negative 3, like that. Alright, so this is the position vector of QC, but to get the actual point C, we just have to combine these two vectors right here. We go Q plus this right here. Yeah, so basically to get the center, so thus, the center or a center as a position vector pointing basically to this, like that, as a vector, from the origin. Again, it's vector, origin, point, same thing in this scenario because the origin is 0, 0s. This is just going to be, and again, this center right here is this part right here. So we want to know this. We know the position vector like that. I'm going to draw it actually for completeness. Yeah, so move it over there. So thus, what we have is, if we have C like this, we know this position vector, this is QC like this. And we also know from here to here, this is just from to Q. Like that. And that's just the point Q as a vector. So then C is equal to the combination of all these things right here. Thus, C equals to Q plus QC, and this equals to, well, Q is negative 1, I think it's 1 and 3. Let's see if we got that right. Yeah, so Q is, Q is 1, negative 1, and 3. Negative 1, 1, and 4, so that's Q. So negative 1, 1, and 4. And then plus QC is just the top one there, 6, 3, negative 3, like that. this equals to, so -1 plus 6 is going to be, well, 6 minus 1 is going to be 5. Then 1 plus 3 is 4. And 4 minus 3 is 1. So then the center is just, the center's at 5, 4, and 1. Yeah, so that's what we get is a sphere. And we know the center and we know the radius. So our equation for when we're asked to find the maximum sphere, the largest sphere we can find is, well, x minus 5 is the center, 5 plus y minus 4 squared, and then plus, actually, it's all plus for a sphere. This is going to be plus, this is going to be z minus 1 squared, and this is going to be equals to, this is the largest sphere that we can possibly do. This equals to the radius squared, so 3 times square root 6 squared. Alright, so we have the origin, we have this all, and this one is just 3 squared is 9. So this is just going to be 9 times 6. The 6 cancels, the square root cancels, so 9 times 6 is equals to 54. So we could just copy and paste this and equate it all. Yes, move it down here. So then this equals to, yeah, this equals to right here equals to 54. Like that. And yeah, this is the largest sphere under the conditions of the question. And just to double check it all, we're going to see it visually. We can graph this using GeoGebra's 3D graphing calculator. There's the link there, and this is our point P, or point Q, P, and C. And there's a sphere right here. Basically, you can create an equation. There's a sphere of Q with center C, radius 3 times square root 6, and it gets you exactly our answer. So x negative 5 and y minus 4 as at minus 1. And then the sphere, the one where we had the 151, is -1, 2, and 3, and 150 there. And you just put the point P, and does it. So automatically does it, and there it is. So we have a sphere. This is in a bluish area in the center. There's all our points there, and we can see them all visually. So there it is, and we can move this around. So we can move this around in 3D, and let's hide the big sphere. There's our small spheres. There's the point Q. There's our point Q right there, and this is, yeah. So the point Q is at the -1, so it's in the back. X is -1, so in the back over there. There's our point P in the center. I'm going to hide the sphere. Yeah, there's how it looks like. So there it is. There's Q, there's P, there's C, and again, if you have this one right here, this is the sphere right here with a radius 3 times square root 6, or square root 54. So that's how it is. And then you have the big giant one, completely exactly on the edge. You could try to zoom in. It's exactly on that edge there. Yeah, it's exactly on. It's actually epic. Let's go back here. Yeah, so it's exactly on that edge. So epic stuff here. I'm just going to zoom out. Okay, so zoom out, move it around, and yeah, right on the edge. So that's amazing stuff. All right, so that is quite fascinating.